It was March 1941 when Edward Nelson stood in the submarine construction bay at Mare Island Naval Shipyard in Vallejo, California. The welding torch cast flickering shadows across his face as he sat during a break, scribbling words of frustration into a worn notebook. There has to be a better way. This is madness. The Navy keeps demanding faster work, but nobody wants to hear what I've got to say. He'd just watched something that made his stomach turn. A whole crew of men, 12 of them, had spent their entire shift just to get one section of deck planking secured. Inside the steel submarine below, in those cramped spaces where scaffolding climbed like metal trees, workers twisted wrenches with aching arms, tightening bolts that came down from above. The bolts had to pull the wooden decks tight against the steel frame, and it was slow, methodical, exhausting work. Hour after hour just to fasten planks that could be installed in minutes if somebody would just listen to him. The traditional method had been used for decades. It demanded precision, yes, but it also demanded time, and time was something America didn't have anymore. Not with war clouds rolling in over the Pacific. Theodore Edward Nelson was 36 years old, born and raised in California. He'd spent 15 years moving through machine shops across the state, learning how metal moved, how electricity behaved, how engineering problems could be solved if only the right people paid attention. What the Navy supervisors didn't know was that this welder had already figured out the answer to their biggest problem. What Nelson himself didn't yet know was that his simple solution, the one they'd reject and throw away, would eventually save the United States Navy more than 50 million man-hours and reshape how warships got built forever. The real struggle had started weeks earlier in those tight spaces below the decks, where the fight against waste happened every single day. It was March 15, 1941, 8 months and 22 days before Pearl Harbor changed everything. Mare Island stretched across 635 acres along the Napa River, about 25 miles northeast of San Francisco. Established in 1854 by Commander David Glasgow Farragut, it had been the first Navy base the country ever opened on the Pacific. By 1941, Mare Island had become the West Coast's premier submarine construction facility. The shipyard never slept. 3 shifts worked around the clock, 7 days a week. As tensions with Japan kept rising, submarine production had become critical. Submarines were what the Navy needed most. About 12,000 civilian workers filled the yards in early 1941, though that number would swell to nearly 50,000 by 1944. Ted Nelson was one of them, employee number 3872. He earned $11 a day, working days from 7 in the morning until 4 in the afternoon. His job involved welding submarine hulls and internal structures. He was good at it, fast, precise, reliable, but he was growing angrier by the day at what he saw as wasteful, inefficient methods. The waste stared him in the face everywhere: wooden deck planking on submarines, destroyers, and aircraft carriers. The Navy had reasons for using wood. It provided better grip than steel when wet. It kept noise levels down when crew moved across it. It insulated slightly against the cold of the steel beneath. And if fire broke out, wooden decks could be repaired more easily than welded steel. But the way they attached those wooden decks was ancient, back-breaking labor and painfully slow. The same procedure that had been used since World War I, it involved a series of complicated steps. First came drilling. Workers had to bore holes through the wooden planks at precise intervals. Those holes had to be countersunk so bolt heads could sit flush with the deck surface. Then workers positioned the planks on the steel framework. Then came the real nightmare. Workers had to build massive scaffolding underneath the deck, inside the submarine or ship compartments. Multiple levels of platforms were needed so people could reach the underside of the steel framework. With the scaffolding in place, workers both above and below had to coordinate. Long threaded bolts went down through the wooden planks and through corresponding holes in the steel. Workers standing below on scaffolding platforms in dark, cramped spaces would thread nuts onto those bolt ends. They'd tighten them with wrenches, pulling the wooden planks hard against the steel framework above. Finally, topside workers would fill the countersunk holes with wooden plugs to create a smooth deck. This entire process repeated for every single section. A submarine might have several hundred square feet of wooden decking needing thousands of attachment points. An aircraft carrier's flight deck could cover tens of thousands of square feet. The labor demands were enormous. Installing the deck on a typical submarine meant putting together a crew of 12 to 16 men working 5 to 7 days straight. 2 full days just went to building the scaffolding. Another day to take it down. What remained was spent installing bolts. Nelson had done this work dozens of times himself. He'd spent countless hours standing on those scaffolding platforms, threading nuts onto bolts in submarine compartments barely 4 feet tall. His back ached from constant bending, his knuckles bore scars from wrenches slipping. His patience had worn thin, but his frustration went deeper than personal discomfort. He could see the bigger picture. War was coming. Everyone at Mare Island knew it. The yard was already behind schedule on submarines. The Navy needed boats in the water, not sitting in construction waiting for decks. Every single day of delay meant one day closer to conflict. America wasn't ready, and Nelson knew there had to be a better way. He'd been turning this problem over in his mind for months, working through it during the routine hours of welding. The solution seemed obvious to him. Instead of bolting from above and threading nuts from below, why not weld studs directly to the steel framework? Weld from above only. No scaffolding needed, no bolts and nuts, no workers crushed in compartments below. Just fast, strong, permanent welds. The concept was straightforward. A threaded stud, essentially a bolt without a head, could be welded to the steel framework in less than a second. Wooden planks would have threaded inserts or special nuts to attach to those studs. The entire operation could happen from topside only. No scaffolding, no below-deck work, no coordination between crews. Nelson had seen stud welding before, but only in limited forms. The technology worked on horizontal flat plates. A small pile of flux powder would be placed on flat steel. A stud would sit in that flux. An electrical arc would fuse the stud to the steel. The problem was that this only worked on horizontal surfaces. Vertical or overhead surfaces, the flux powder just fell right off. Naval construction demanded welding in every position imaginable: vertical, horizontal, overhead, at angles. This was the question that had stumped welding engineers for 20 years. How to make stud welding work when surfaces weren't horizontal? Nelson thought he had it. The answer was so simple he almost laughed when it hit him. Don't use loose flux powder. Put the flux inside a small ceramic cap. Attach that cap to the end of the stud. Now the flux stays put, no matter what position you're working in. He sketched the idea in his notebook. A handheld welding gun. A spring-loaded mechanism to press the stud against the steel. An electrical trigger to create the arc. A disposable ceramic flux cap on each stud. The whole operation would take less than 1 second per stud. One worker could weld dozens of studs in the time it currently took to install a single bolted connection. He took his idea to his supervisor, a Navy lieutenant named Morrison. The meeting lasted less than 5 minutes. Morrison barely glanced at the sketches. "We have established procedures, Mr. Nelson. We follow Navy specifications. If you want to spend your time welding instead of supervising bolts, stick to what you're already doing." Nelson approached the shipyard's chief welding engineer next, a civilian contractor named Hartwell. He explained the time savings, the reduced labor costs, the elimination of scaffolding expenses. Hartwell was kinder than Morrison, but just as dismissive. "Son, people far smarter than either you or I have been trying to solve this problem for 20 years. If it was that simple, somebody would have done it already. Besides, the Navy has specifications. You can't just change procedures because a welder has a hunch. You'd need approval from the Bureau of Ships in Washington. You'd need engineering studies. You'd need prototype testing. That takes years." "We don't have years," Nelson protested. "We need submarines now." Hartwell shrugged. "That's not my problem, Mr. Nelson. My problem is building boats according to approved specifications. Your job is doing the welding you're paid to do." Nelson left the meeting angry and broken-hearted. He'd offered an innovation that could save thousands of hours per submarine. They'd dismissed him without even considering it seriously. Not because his idea was flawed or wouldn't work, but because he was just a welder. Because changing procedures meant paperwork and bureaucracy. Because following the rulebook mattered more than trying something new. He made one final attempt, writing a formal letter to the shipyard commander, Captain Thomas Whittles. He carefully explained the current inefficiency, proposed the stud welding solution, and estimated the time and cost savings. He submitted it through proper channels, following the official procedure for worker suggestions. 3 weeks later came the response, a form letter thanking him for his interest in improving shipyard efficiency, a polite explanation that technical proposals went to the Bureau of Ships Engineering Review Board, a note that his suggestion had been forwarded for consideration, a realistic timeline, 18 to 24 months for the review process. He'd be notified if his proposal moved forward for further study. 18 to 24 months. By then, the war might be over or lost. Nelson crumpled the letter and threw it away. That evening, he made a decision that would transform his life and change naval history. If the Navy wouldn't listen, he'd prove it himself. He'd build it himself, demonstrate that it worked, and then they'd have to pay attention. He cleared space in the garage behind his small cottage in Vallejo. His wife Emma watched with worry as he began gathering scrap steel and welding equipment. "Ted, you're going to get yourself fired," she said. "You're supposed to be working on Navy projects, not your own inventions." "This will help the Navy," he replied. "They just don't know it yet." Over the following weeks, working evenings and weekends, Nelson built his first prototype stud welding gun. The design was crude but practical: a pistol grip handle, a spring-loaded plunger to hold and press the stud, an electrical trigger connected to the welding power supply, a quick-release mechanism to load new studs. The crucial breakthrough was the flux cap. He tried different ceramic materials, different flux compositions, different cap designs. After dozens of attempts, he developed a cap that held the flux securely, allowed proper arc formation, and could be produced cheaply. By May 1941, he had a working prototype. He tested it on scrap steel in every position he could imagine: horizontal, vertical, overhead, at various angles. The gun performed flawlessly, studs welded in less than 1 second. The weld strength exceeded traditional bolted connections. Most importantly, it required no access from below the surface. He brought the prototype to work and demonstrated it to several fellow welders during lunch. They were impressed and excited. "This could save us so much time," one said. "You need to show Morrison," another suggested. Nelson shook his head. "I already showed Morrison. He wasn't interested." "Then quit and start your own company," a third welder said. "Sell your gun to shipyards all over the country. You'll get rich." The idea had never occurred to Nelson. He was a welder, not a businessman. He had no money, no manufacturing operation, no business knowledge. But the more he thought about it, the more it made sense. If the Navy wouldn't use his invention, perhaps private shipyards would. Kaiser Shipyards in Richmond was hiring. Bethlehem Steel's shipyard in San Francisco was expanding. Shipyards dotted the entire West Coast, all struggling with labor shortages and production deadlines. On June 20, 1941, Ted Nelson submitted his resignation to Mare Island Naval Shipyard. His supervisor tried to convince him to stay. "Nelson, you're a good welder. Don't throw away a steady job for some crazy invention." But Nelson had made his choice. "I'm going to build welding guns," he said. He shared this determination with Morrison. When the Navy eventually returned seeking to purchase them, Nelson hoped his former supervisor would recall their exchange. With just $11 remaining, a workshop filled with equipment, and unwavering belief in his innovation, Nelson departed Mare Island. On July 1, 1941, he officially established the Nelson Specialty Welding Equipment Corporation. The Reconstruction Finance Corporation, a Depression-era government lending program designed to support emerging businesses, provided him with a $95,000 loan. He secured a modest workshop in Vallejo and began production of his stud welding guns. Those opening months proved grueling. He possessed no established clientele, no track record, no way to reach potential buyers. Local machine shops and fabrication businesses received visits from this determined entrepreneur each time he'd demonstrate his equipment and highlight the considerable time it would save them. Skepticism dominated their reactions. Only a handful showed sufficient interest to test one of his demonstration units. The orders materialized gradually, almost imperceptibly at first. By September 1941, he'd successfully sold 18 welding guns alongside several thousand flux-capped studs. Then came December 7, 1941, a date that transformed everything. Pearl Harbor changed the nation's trajectory overnight. The attack leveled or seriously damaged 8 battleships, 3 cruisers, 3 destroyers, and 188 aircraft. The casualty count reached approximately 2,400 Americans. War had arrived on the nation's doorstep. Suddenly, constructing vessels wasn't simply valuable anymore. It became essential to national survival. The shipbuilding sector experienced explosive growth within days of the attack. Kaiser's shipyards commenced Liberty ship production at breathtaking speed. Mare Island Naval Shipyard received urgent submarine construction assignments. Bethlehem Steel and competing yards implemented triple-shift operations. Yet every facility confronted an identical challenge: manufacturing vessels at sufficient pace. Conventional approaches consumed too much time, demanded excessive labor, and wasted irreplaceable hours. Nelson's telephone rang constantly. Purchasing managers who'd rejected his concept mere weeks before now sought substantial orders. Kaiser's shipyards requested 50 welding guns and 10,000 studs. Bethlehem Steel placed an order for 40 units. Mare Island Naval Shipyard itself, where Nelson had faced rejection months earlier, requested 60 guns and 20,000 studs. His old supervisor Morrison managed the purchase paperwork. No acknowledgement of Nelson being correct arrived. No apology surfaced. Just a curt official requisition accompanied by a demand for immediate fulfillment. Within a month following Pearl Harbor, Nelson's small workshop couldn't satisfy the incoming requests. Orders exceeded manufacturing capability substantially. He required a genuine factory, expanded workforce, superior machinery. He obtained a larger building in San Leandro, situated several miles south of Oakland. The structure occupied an isolated spot within farmland, unremarkable in appearance, yet offering adequate space, electrical capacity, and potential for growth. By March 1942, his payroll had reached 20 employees. June brought 50 workers. September saw the workforce climb to 150. The facility operated continuously, producing 30 welding guns daily from its assembly line. Stud output reached thousands each day. Every significant West Coast shipyard employed Nelson's stud welding equipment. The feedback proved remarkable. Work installing submarine decking that previously consumed 12 workers across 6 days now required merely 3 workers for a single day. Eliminating temporary work structures freed 2 additional days and workers for alternate assignments. These welds exhibited superior strength compared to traditional bolted joints. Wooden deck sections could be removed and installed again with greater simplicity for upkeep or corrections. At Mare Island Naval Shipyard, submarine construction accelerated substantially. Between 1941 and 1945, the yard constructed 17 submarines, with progressively reduced construction timelines as methodologies improved. Though stud welding represented merely one innovation, it functioned as a crucial component within the broader efficiency framework. Mid-1942 witnessed stud welding applications expanding beyond decking to include pipe hangers, cable assemblies, equipment attachment points, and internal reinforcement connections. Whenever steel fastening required speed, stud welding delivered advantages. The Navy's Bureau of Ships, which had previously disregarded Nelson's initial submission, commenced detailed examination of his technique. Research groups evaluated joint quality, longevity, and failure characteristics. The findings validated what Nelson had maintained consistently. These joints weren't simply faster. They genuinely surpassed conventional approaches in both durability and consistency. November 19, 1942, brought an unexpected moment. Less than 1 year following his resignation from his $11 per day position, Ted Nelson received an unannounced delegation. 5 uniformed Navy personnel arrived at his San Leandro facility. Captain Harrison, representing the Bureau of Ships, delivered their message. "Mr. Nelson, we've concluded our assessment of your stud welding methodology. Our evaluation indicates your innovation has conserved approximately 5 million working hours across submarine and naval vessel construction during these past 10 months. This quantity will expand significantly as additional shipyards incorporate your system. He continued. The Navy Secretary and United States government have authorized me to present you this recognition for outstanding wartime contribution. Nelson found himself speechless. These were the individuals who dismissed his proposal. They disregarded his requests. His resignation and personal sacrifice had been necessary to demonstrate his concept's validity. Yet now they offered him official recognition. Captain Harrison apparently noticed Nelson's inner struggle. I've reviewed your early 1941 proposal to Mare Island, Mr. Nelson. That submission received inadequate consideration. The Navy bears responsibility for this oversight, and I apologize. Nevertheless, pursuing independent development has accelerated implementation beyond normal governmental acquisition timelines. Sometimes serving your nation requires circumventing official procedures and simply delivering results. Nelson accepted the award, experiencing mixed reactions, satisfaction regarding his vindication and accomplishment, yet also resentment toward institutional resistance that nearly prevented this breakthrough. Wartime production demands intensified. Nelson's enterprise required expansion, establishing a second manufacturing facility in Camden, New Jersey, during March 1943. This eastern location supplied facilities in New York, Philadelphia, Norfolk, and Charleston. By mid-1943, the company's workforce exceeded 400 employees, generating approximately $4 million annually. Nelson maintained a grueling schedule, investing 16 hours regularly within the factory. His appearance remained unchanged, standard shop attire of tan trousers and shirts. His personal compensation stayed modest at $1,000 monthly. Profits flowed entirely into expansion, machinery, and debt reduction. Yet his wartime contribution extended beyond measure. The initial 5 million-hour projection from late 1942 represented only the beginning. As stud welding became universal across naval construction, time reductions multiplied dramatically. By 1943, applications extended beyond submarines to encompass aircraft carriers, battleships, cruisers, destroyers, and countless auxiliary vessels. Essex-class carriers, constructed by Newport News Shipbuilding and other facilities, incorporated Nelson's equipment extensively for flight deck installation and internal arrangements. Each carrier necessitated roughly 20,000 studs. The Navy commissioned 24 Essex-class vessels during wartime. Iowa-class battleships utilized stud welding for deck surfacing, equipment positioning, and armor fastening. Baltimore-class cruisers integrated the technology comprehensively. Destroyer escorts, amphibious assault craft, patrol vessels, every naval category benefited from accelerated, stronger fastening approaches. Submarine construction demonstrated the most dramatic advantages. Mare Island Naval Shipyard, where Nelson had labored and where his proposal had been rejected, evolved into a supremely effective submarine manufacturer. The installation produced 17 submarines with progressively shortened construction durations. Portsmouth Naval Shipyard in New Hampshire emerged as the preeminent submarine builder, delivering 79 submarines between July 1940 and July 1945. Portsmouth's exceptional results emerged from diverse innovations, though Nelson's stud welding represented a fundamental enabling technology. The facility embraced his methodology extensively, deploying it throughout internal structures beyond simple decking. The construction metrics reflected this achievement. Portsmouth launched 3 submarines simultaneously on January 27, 1944, Redfish, Ronquil, and Razorback. A 4th vessel, Scabbard Fish, departed the ways that identical day. 4 submarines in 24 hours. No facility has replicated this accomplishment before or since. Portsmouth reached its production zenith, completing 32 submarines during 1944. This represented approximately 1 submarine per 11 days. Gato-class submarines, constituting the bulk of production, averaged 12 months from initial laying through commissioning at Portsmouth. This substantially outpaced comparable production at rival yards. Electric Boat Company in Groton, Connecticut, constructed 74 submarines during hostilities. Manitowoc Shipbuilding in Wisconsin, positioned on the Great Lakes hundreds of miles from ocean access, constructed 28 submarines, subsequently transported via the Mississippi River toward the Gulf. Collectively, America constructed 203 submarines throughout World War II. Each submarine incorporated thousands of stud-welded connections. Each individual stud represented minutes of labor savings. Multiply those minutes across thousands of studs per boat, hundreds of vessels, and the cumulative time reductions reached staggering proportions. Yet submarines constituted merely one component. The genuine production volume originated from surface and merchant construction. The Liberty Ship effort, administered through maritime authorities and primarily undertaken at Kaiser facilities, produced 2,710 cargo vessels. Every Liberty ship incorporated 5,000 to 8,000 stud attachments for deck components, cargo mechanisms, armament supports, and structural fittings. Victory ships, representing faster advanced designs, followed comparable standards. The construction magnitude was unprecedented in human experience. Liberty ship launches peaked during 1943, with 3 vessels departing yards daily, 75 monthly, 900 yearly. Such production proved achievable solely through revolutionary construction approaches. Advanced preparation, integrated assembly, concentrated labor specialization, purpose-built equipment, and accelerated fastening solutions. Stud welding represented one element within this broader construction revolution. Nevertheless, it functioned as a vital element. Eliminating temporary structures permitted workers' reassignment. Installation quickness diminished overall assembly duration. Joint quality guaranteed these hastily constructed vessels could endure Atlantic tempests and hostile assault. Spring 1943 brought formal Navy recognition. May 11, 1943 brought the Navy Secretary presenting Nelson's specialty, Welding Equipment Corporation, with the Army-Navy E Award for Production Excellence. Established during July 1942, this recognition honored companies achieving exceptional wartime manufacturing results. Production quantity and quality standards determined recipients. Approximately 5% of wartime contractors received this distinction. The award comprised factory pennants and personnel lapel pins. Ceremonies at the San Leandro installation included military protocols, Navy officers, Army personnel, and civic representatives. Factory workers, those personnel who'd endured exhausting schedules supporting production goals, received their pins with justified pride. Ted Nelson, dressed in his characteristic work attire, received the pennant and addressed his workforce. "We accomplished this not pursuing awards or glory. We performed this function because our nation required it. Every stud manufactured, every gun assembled, facilitates returning our servicemen safely. That recognition suffices abundantly." The Navy extended its recognition further. Facilities sustaining exceptional results through the subsequent 6 months qualified for star additions to existing pennants. Nelson's operation secured its initial star during November 1943. May 1944 brought the second star. By wartime conclusion, Nelson's Specialty Welding Equipment Corporation had accumulated 2 stars. Merely a handful of enterprises achieved this status. The citations specifically referenced 50 million estimated working hours conserved across naval construction. 50 million hours. Consider this magnitude. 50 million hours represents approximately 5,700 years. Operating 8-hour workdays consistently, one individual would require 19,000 years accumulating 50 million hours. This remarkable economy derived from a solitary innovation, a spring-loaded welding apparatus and ceramic flux-containing capsule. The time reductions converted immediately into accelerated ship deployments. Submarines pursuing Japanese commerce, destroyers escorting supply lines, aircraft carriers executing aerial bombardment, amphibious transports delivering assault forces. Every expedited vessel delivery amplified combat effectiveness, enhanced supply capabilities, and preserved personnel. The strategic consequences proved impossible to quantify. However, Nelson's contribution generated unexpected secondary advantages. Stud welding demanded considerably less expertise than conventional fastening or traditional fusion joining. Minimal preparation allowed recently hired personnel to execute stud operations proficiently and securely. This became essential when wartime progressed and worker availability tightened. Unprecedented female employment emerged throughout shipyards. Famous cultural imagery represented Rosie the Riveter, but equally significant were women welders. Women discharged stud welding responsibilities, positioned deck materials, installed assemblies, and developed considerable proficiency within the discipline. Mare Island's employment peaked near 50,000, including roughly 9,000 women. Kaiser's operations hired hundreds of thousands, with nearly 30% female representation. These personnel required equipment and methodologies, permitting rapid skill acquisition and secure operation. Stud welding satisfied these prerequisites precisely. By 1944, warfare had shifted decisively, supporting Allied interests. American production capabilities surpassed adversary manufacturing combined. The United States manufactured additional vessels, aircraft, armored vehicles, and weaponry than Germany and Japan collectively produced. President Roosevelt's arsenal of democracy functioned at maximum capability. Nelson's stud welding guns represented one modest component within this colossal industrial mobilization, yet modest elements maintained significance. During hostilities, efficiency translates into preserved existence and conquered adversaries. Accelerated ship delivery expanded naval force projection. Enhanced naval presence devastated enemy shipping, captured territories, and intensified opposition strain. American submarines prowled the Pacific waters throughout the war, and their impact proved devastating to Japan's ability to sustain operations. These underwater hunters sank more than 1,000 Japanese merchant vessels, destroying approximately 5 million tons of cargo and supplies. Beyond the commercial shipping, they claimed 1 aircraft carrier, 8 battleships, and countless cruisers and destroyers, a staggering toll on Japan's naval forces. Yet this success rested on one crucial advantage. America's shipbuilders worked faster than Japan could replace lost submarines. When the conflict began in December 1941, Japan actually possessed a larger submarine fleet than the United States. But over the course of the war, Japan managed to construct only 126 submarines, while American yards launched 203. That difference in production capacity meant that every month mattered, and every week a new submarine entered service represented another week of hunting. The aircraft carrier program revealed an identical pattern of American industrial dominance. In December 1941, the Navy possessed 7 carriers. By the time Japan surrendered in August 1945, that number had swelled to 99 carriers of various types. The Essex-class fleet carriers became the heart of this expanding force, with 24 completed and each capable of carrying up to 90 aircraft. These fast carrier task forces, built around the Essex-class vessels, seized control of the Pacific beginning in mid-1943 and never surrendered it. These ships shielded Japanese positions from attack, launched devastating airstrikes deep into enemy territory, provided protective cover for amphibious landings, and clashed with Japanese naval forces in decisive battles. The Battle of the Philippine Sea in June 1944 became legendary among pilots. American carrier aircraft destroyed more than 600 Japanese planes in what aircrew nicknamed the Great Marianas Turkey Shoot. This overwhelming victory was only possible because America positioned more carriers in the right locations at precisely the right moment. Faster construction meant faster deployment, and faster deployment meant America could project power where it was needed most. The massive D-Day invasion on June 6, 1944, required an armada of 7,000 ships and landing craft, the largest amphibious assault in human history. Creating this enormous fleet demanded that American and British shipyards produce landing craft by the thousands, month after month. These landing craft were simple but effective vessels, flat-bottomed boats designed to run straight up onto beaches and discharge their cargo of troops and equipment. Their crude construction belied their critical importance, requiring rapid assembly with reliable fittings throughout. Stud welding proved perfect for this work, allowing workers to attach cargo ramps, davit mounts, and deck fittings quickly and securely without complicated assembly procedures. The technology Nelson had developed for submarine construction found applications throughout the entire landing craft fleet. After Germany's surrender in May 1945, American military planners redirected all remaining resources toward defeating Japan. Operation Downfall, the planned invasion of Japan, was scheduled to commence in November 1945. Military strategists anticipated this operation would demand more ships, more landing craft, and more logistical support than any campaign that had come before it. Shipyards across America geared up for yet another massive surge in production. Then, on August 6, 1945, atomic bombs fell on Hiroshima and Nagasaki. Japan surrendered on August 15th, and the Second World War ended with stunning abruptness. The enormous military production machine that had consumed the nation's resources for nearly 4 years began grinding to a halt. Military contracts were cancelled almost immediately. Workers received pink slips. Shipyards closed their gates or transitioned to civilian work. Nelson's company, which had employed over 400 workers at its wartime peak, suddenly faced an uncertain future. Military orders vanished almost overnight, threatening the survival of the entire enterprise. But Ted Nelson had prepared for this possibility. Throughout the war years, he had contemplated what stud welding might accomplish in peacetime applications. The technology was not confined to naval construction. It could serve any industry that fabricated steel structures. Construction firms building new structures, steel fabricators assembling components, automotive manufacturers assembling vehicles, bridge builders, tank builders, makers of pressure vessels, and countless other industries could all benefit from faster, more reliable attachment methods. Nelson shifted his focus toward civilian markets. He marketed his stud welding systems to construction companies, steel fabricators, and industrial manufacturers. The post-war construction boom that swept across America provided abundant opportunities. The nation was building interstate highways, bridges spanning rivers, skyscrapers rising into city skylines, and entire suburbs expanding outward from urban centers. All of these projects required extensive steel fabrication and attachment work. By 1948, Nelson's company had successfully transitioned to peacetime production. The business was smaller than during wartime, but it remained stable and continued growing. The company continued innovating, developing new stud designs, improving the welding guns, and discovering specialized applications for the technology. In 1950, Nelson sold his company to TRW, a major industrial conglomerate. This sale provided Nelson with financial security and allowed him to step back from day-to-day management, though the Nelson name remained on every product. TRW maintained the brand recognition Nelson had carefully built over the years. Over subsequent decades, ownership changed hands repeatedly. TRW sold to Fast & Tech Incorporated in 2000. Don Casters Group Limited acquired Fast & Tech in 2007. Stanley Black & Decker purchased the industrial division in 2018. Yet through all these transformations, the Nelson brand persisted. Today, Stanley Engineered Fastening manufactures and markets Nelson's stud welding products to customers worldwide. The technology Nelson first sketched in his notebook and refined in his garage in Vallejo remains in use across the globe. Modern stud welding has evolved dramatically from Nelson's original invention. Contemporary systems employ inverter power supplies that provide precise arc control, while automated equipment handles high-volume production runs. Robotic welders apply studs in automotive assembly plants with mechanical precision, yet the fundamental principle remains unchanged. A stud, a flux cap, a spring-loaded gun, and an electrical arc. 1 second per stud, no complex scaffolding required. The applications have extended far beyond the shipyards where Nelson's invention was born. Construction workers use stud welding to secure metal decking onto steel beams in skyscrapers reaching toward the sky. Bridge builders rely on the technology to install guardrail posts and lighting fixtures. Nuclear power plants employ it for cable trays and equipment supports. Automotive manufacturers integrate it throughout vehicle bodies for grounding points and trim attachment. The problem-solving tool Nelson created for a specific naval construction challenge has become indispensable across virtually every industry that works with steel. Perhaps the most poignant legacy of Nelson's invention appears in the restoration of historic ships. The battleship USS Texas remains one of only 7 ships that served in both World Wars. The vessel now sits in a dry dock, undergoing extensive restoration. Hull plates corroded by decades of exposure need replacement, and deteriorated fittings require attention. The restoration team discovered that modern Nelson stud welding equipment proved ideal for this delicate work. They can attach new steel plates using the identical technology Ted Nelson invented 8 decades ago. Similarly, the submarine USS Pampanito, a World War II boat preserved as a museum in San Francisco at the Embarcadero, relies on Nelson welding for ongoing maintenance work. The vessel hosts over 100,000 visitors annually, and keeping the aged submarine safe and functional demands constant attention. Nelson equipment allows the volunteer restoration crew to perform necessary welding tasks efficiently without requiring certified welders for every single operation. Ted Nelson lived long enough to witness his invention's impact extend far beyond what he could have imagined that day in 1941 when he first sketched his idea in a notebook. He watched stud welding become standard practice throughout the shipbuilding industry. He saw it adopted by industries worldwide. He witnessed his name become synonymous with a welding process. Nelson died in 1994 at age 89, having lived long enough to see the Cold War end and witness the transformation of the world his generation had sacrificed to protect. The raw statistics provide part of the story. 50 million man-hours saved, 2 Army-Navy awards, thousands of ships constructed faster than previous methods allowed, billions of studs manufactured and installed, yet numbers alone cannot convey the full magnitude of the impact. Behind those statistics were countless sailors who came home because their submarine was completed in time to deploy with the fleet. Marines who survived assaults because landing craft were available when needed. Families who remained whole because the war ended sooner than anyone had predicted. The true measure of any innovation lies not merely in efficiency gains, but in lives preserved. Ted Nelson, the welder earning $11 per day, who was told his idea was impractical and unworkable, ultimately saved more lives than many celebrated combat heroes. He accomplished this not through weapons or destruction, but through welding and construction. The rejection he initially faced was not uncommon. History brims with innovators dismissed by established authorities. Wilbur and Orville Wright were told that powered flight was impossible. Henry Ford was ridiculed for suggesting automobiles could be mass-produced affordably. Chester Carlson spent years searching for someone willing to develop his xerography process. What distinguished Nelson was his absolute refusal to accept rejection as final. He did not waste energy arguing with bureaucrats or attempting to convince skeptics. He simply resigned from his position, risked his personal savings, and proved his concept functioned as intended. The market then did the persuading for him. This approach embodied American innovation at its finest. Not seeking permission, not adhering to established procedures, not assuming that things must be done the way they had always been done. Simply identifying a genuine problem, developing a workable solution, and possessing the determination to implement it despite institutional resistance and official dismissal. Mare Island Naval Shipyard, where Nelson worked and where his revolutionary idea was initially rejected, ceased operations in 1996 after 142 years of continuous service. During its lifetime, the yard constructed 512 vessels and repaired thousands of others. The shipyard was responsible for building 44 submarines, including the final nuclear submarine constructed in California, USS Drum, launched in 1970. The facility was designated a California Historical Landmark in 1960, and portions were designated as a National Historic Landmark District in 1975. The former shipyard is currently being redeveloped as a mixed-use commercial and residential space. Several historic structures remain standing, including the chapel, dry docks, and various industrial buildings that witnessed decades of activity. Walking through these preserved areas allows visitors to imagine the intense, almost frantic activity during the war years when tens of thousands of workers labored around the clock constructing submarines. Building 46, the old pipe shop that remained operational until 1984, now houses a small museum. The exhibits display tools, photographs, and artifacts, documenting the shipyard's rich history. However, there is no dedicated exhibit about Ted Nelson, no monument commemorating the welder whose invention saved 50 million man-hours. His story remains largely unknown, except among welding professionals and maritime historians. This obscurity probably would not have troubled Nelson. He was not motivated by fame or public recognition. He was focused on solving problems, making processes work more efficiently, and contributing to his country's war effort. The fact that his solution functioned, that it conserved time and saved lives, that it fundamentally changed an entire industry, these accomplishments provided sufficient reward. Yet there remains an important lesson for every generation. Genuine innovation frequently emerges from unexpected sources, not from credentialed experts holding advanced degrees, but from working people confronting problems daily who understand exactly how to fix them. Not from corporate research laboratories, but from garage workshops where determined tinkerers experiment relentlessly until they discover solutions. Not through official channels, but through individuals possessed of sufficient courage to risk everything on an idea they genuinely believe in. The next transformative innovation might originate from a welder in a shipyard, a mechanic in a workshop, a nurse working in a hospital, a teacher leading a classroom. It might come from someone that official channels regard as unqualified, someone bureaucrats order to follow established procedures, someone experts assure is wasting time pursuing an impossible objective. History strongly suggests we should listen to these people carefully, not because every single idea will succeed, but because the occasional idea that does work can fundamentally alter everything. Ted Nelson's ceramic flux cap was merely a small piece of ceramic. His welding gun was simply a spring-loaded tool. Yet combined, they eliminated the need for scaffolding, conserved enormous amounts of time, increased worker safety, improved construction quality, and dramatically accelerated ship production at a critical moment when the outcome hung in the balance. 50 million man-hours, roughly 5,700 years of labor, represents the direct construction time savings alone. This figure does not account for the strategic advantage gained through faster ship deployment. It does not measure the lives spared because submarines reached the Pacific theater sooner than would otherwise have been possible. It cannot calculate the morale surge from exceeding production targets. It does not quantify how the rapid expansion of American naval power served as a deterrent when enemies anticipated slower growth. The complete impact of Ted Nelson's invention may never be fully comprehended, but we can state with absolute certainty that America's victory in the Second World War depended on industrial capacity no less than military valor. The individual battles were won by soldiers, sailors, and Marines who fought courageously. But the war itself was won by workers, engineers, and innovators. People like Ted Nelson, who examined problems and fixed them, who refused to tolerate inefficiency when improvement remained possible, who grasped that in total war, every minute preserved in production directly translated to lives preserved in combat. As our society confronts the significant challenges of the 21st century, this lesson remains profoundly relevant. The problems demanding our attention, climate change, resource depletion, crumbling infrastructure, require innovation across all levels of society. Solutions will originate not solely from prestigious universities and corporate laboratories, but from working people who perceive problems with clarity and develop practical solutions. The next Ted Nelson might be perfecting a more efficient solar panel in a garage workshop. The breakthrough innovation might come from a factory worker who understands precisely where time and energy are being wasted. The next major efficiency revolution might begin with someone the establishment has already dismissed as lacking qualifications. We must listen to these voices. We must actively encourage innovation from all quarters. We must dismantle barriers separating problem identification from solution deployment. We must recall that countless revolutionary innovations emerged from people operating outside formal systems because those systems refused to pay attention. Ted Nelson began as an $11 a day welder. He became a millionaire industrialist whose technology preserved his nation. Yet he never abandoned his humble origins. He never affected pretense. He never claimed to be anything beyond a mechanic who observed a problem and repaired it. When interviewed later in life about his remarkable success, Nelson would simply shrug and remark that he had simply built a better mousetrap, and the world came to his door. It was not brilliance, he insisted. It was merely practical common sense. but common sense applied at the proper moment with genuine determination and persistent effort can reshape history itself. This constitutes Ted Nelson's genuine legacy. Not the 50 million hours saved, not the military awards received, not the global corporation that continues bearing his name. His true legacy is the tangible proof that a single person possessing a solid idea and the resolve to execute it can genuinely make a difference. This inheritance persists every moment a welder engages a stud welding gun, every time a ship achieves faster construction than older methods permitted. Every moment someone examines an inefficient procedure and wonders aloud whether a superior approach exists. Ted Nelson posed that question in 1941. His answer helped determine the outcome of a war. What question are you asking today? And critically, when established experts declare something cannot be accomplished, when administrators insist you follow procedure, when doubters dismiss your concept as worthless, will you possess the courage to demonstrate they are mistaken? The historical record of innovation indicates that occasionally the wisest action is refusing to defer to experts, trusting your own judgment, and constructing the solution you know will function correctly. Ted Nelson made precisely this choice. 8 decades later, welders throughout the world continue using his invention daily without exception. And somewhere, possibly in a modest garage or workshop, the next Ted Nelson is sketching an idea that everyone insists cannot possibly work. But they will be wrong, because the greatest innovations do not emerge from obedient adherence to procedures. They originate from people who recognize a problem, possess the knowledge to fix it, and refuse to surrender when told no.